Sir, yes, sir.
Who is the host? Very good evening, one and all. Am audible?
Very good evening,
audible,
sir.
sir. Good evening, sir.
వినపడుతుందా నా వాయిస్?
Good evening,
voice
sir.
వినిపిస్తుంది, sir.
హలో.
Hello. Good evening, sir. Good evening, sir. It is audible.
Now tell me. Now I am audible?
Yes, yes, sir.
Yes, sir. Yes, sir.
Okay, okay. Today morning, some interruptions. Some head of the department taken the class. Okay. All of you listen topology class today's morning.
Yes, yes, sir.
Yes, sir.
Okay. Yes, yes. I'm continuing the class. Just give a minute. Why is very strength low? Only 10 members is there. So shall I start without late today? So go ahead with express the following permutations and the product of the disjoint cycles here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 9, 3, 5, 1, 7, 6, 2, 8, 4. Again, I'm writing 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 3, 5, 1, 7, 6, 2, 8, 4. Anyone tell me the product of the disjoint cycles? Anyone tell me?
Sir, screen is not visible.
Okay. I will share. I will
Yes,
share.
sir.
I will share. Okay. Now it is visible?
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 3, 5, 1, 7, 6, 2, 8, 4. How many disjoint cycles? Anyone tell me? See here, 1, 9, okay? 9, 4, 4, 1, 19. That means 1941 disjoint cycle. Correct? Hello?
Sir.
Are you? I'm audible now. Please.
Yes, sir. Yes, sir.
194. Then again 4.
19. Yeah.
194. Then again 2 3 3 5 5 7 7 2 and 2 3. Am I correct? Then we can take the 2 3 5 7. It is correct or not? Why?
Yes,
because
2 3 5. Yes, sir.
So again, we did not take 6 here. Why? Because the same number has been there. So there,
same
so the two, yes, the two disjoint cycles here. So this is a 194 and 2 3 5 7 here. We can take that. Now transpositions. Anyone tell me the transpositions? Transpositions. Tell me anyone.
Sir, voice breaking.
Now my side, your side only. I am very clear. Now clear. What are the transpositions? Tell me.
Yes.
1419. We can write it. Two 7 2 5 2 3. It is a disjoint. It is a transpositions or not? All of you listening? 191 194 27 25. This is called, we can call it as transposition. A transposition cycle of length is how much? Hello? Please tell me, respond. What is the transposition cycle of length? Sultana, Tulsiram and Samos, Fatima, Lakshminarayana, Kavita. So all of you, please respond. Anyone, it is right or wrong? Please respond.
1.
How ma? 1942357. Very good. You have responded very good. 1942357. What is the cycle length? It is a 2 or not?
194.
194 is 1 amma. 2357 is 2. Therefore, a transposition cycle length is 2. Why? Because we can take the numbers 1942357. We can, from there, disjoint cycle 1942357. We are taking the transpositions from there. 1942357. We are taking, that is 1914 is one cycle. 272523 is one cycle. So therefore, we can, the cycle of the length is 2 or not?
Yes, sir. 1, 2, 3, 4, 5, 6.
Why are you? ఎందుకు అట్లా కన్ఫ్యూజ్ అవుతున్నారు? You are not understanding?
Voice is not audible, sir.
Now. Hello? Now audible?
Yes, sir.
Now audible? Hello?
Yes, sir. Yes, sir.
Anyone respond, please?
Yes, sir.
I am audible?
Yes, sir. Yes, sir. Yes, sir.
Now audible? Now I am audible?
Yes, sir.
Yes, sir.
Yes, sir. Sir, audible, sir.
Okay.
Yes, yes.
Yes,
sir.
Yes, pins has been changed. So then next time going to the 4th unit, and permutations I will tell at that come, I state and prove. Very important, first silo. In the first silo, second silo, third silo theorems is there. I am today telling first silo theorem. So state and prove first silo theorem here.
Sir, which page number, sir?
You can see the 5th unit. I written my notes. That's why I'm telling here. State and prove. Then after the class completion, then I will tell you. Don't worry about it. Okay. State and prove first silo. Let G be a finite group. Let P be a prime number. P be a prime number and or a non-negative integer such that P power R divides That is a modulus of G. So then G has a subgroup of G of order P power R. See here, all of you. State and prove first silo theorem. They will ask the statement or directly state and prove the first silo theorem. Let G be a finite group. Let J be a finite group. Let P be a prime number. Means the prime number and R be a non-negative. What is means non-negative integer?
Positive integer.
Positive. It's a positive.
Positive
Non-negative
numbers.
is positive, sir.
Positive integer P power R. It is divided by modulus of G. So therefore G is a subgroup of order of P power R with. Then we are taking the proof here. So we can take here proof. Then R is equal to 0. We are taking R is equal to 0. Then E is the, what is E here?
Identity element.
Identity.
Very good. This is subgroup of G of order P power R we can take here. So therefore then E is the subgroup of R. So therefore is a subgroup of order of P power R. So therefore R greater than 0. Then we can write here modulus of G greater than P we can take here. So therefore we use induction of G. What is the induction? What is the meaning of induction? What is the meaning of induction? Anyone tell me? What is the induction of modulus of G? Hello?
Itself.
Tell me. Tell
Itself,
me.
sir.
Itself only. Inka anyone?
One.
Itself to G. Itself to G. So it is an induction to the G. So we can assume that here. Modulus of G is equal to the P. So therefore R is equal to 1. And G is itself. G is itself is a subgroup. Itself is a subgroup of order P power R. We can take itself here. So therefore assume here modulus of G is equal to n greater than P, and that the theorem is true for all groups of order less than n. So and that this theorem is true for all groups of order less than n we can take here. So therefore in the case one we have to take here. The case one we are taking here, suppose P means what is the prime na?
Yes, sir. Yes, sir.
Suppose P defines center ZG of G. ZG means what?
That means integer.
Integer of integer, sir.
Integer. So ZG of G. So therefore ZG is an abelian group. By Cauchy's theorem. By Cauchy's theorem for abelian groups. By Cauchy's theorem for abelian groups. So therefore it exists here. It exists the condition that is A belongs to, that is what you told, the integer Z belongs to G. So therefore we can write here order of A is equal to P. We can write here. So now the subgroup is equal to what we have right here. Subgroup of A is equal to N. But the subgroup, please unmute. Therefore subgroup of order of A is equal to N we can write here. So therefore generated by in A capital G is a normal subgroup of G. Is a normal subgroup of. So if the generated elements of G is a normal subgroup of G, the condition is correct. Yesterday class I told. It is correct or not?
Yes, sir.
Then only one student responding. Okay. The quotient group I am telling you, G by N has order. Therefore, it is a less than prime number, that is, we can take here P. So therefore, already told in the Lagrange's theorem also here. So therefore, we can write G by N is equal modulus of G by modulus of N. So it's equal, we can write modulus of G by P. So and hence we can write here P power R minus. So G by N, G modulus of G by modulus of N, A by G by P. We can write P power R minus 1 by the divides of G by N. We can write it or not from the above condition.
Yes, sir.
So
Yes,
therefore,
sir. Right, sir.
therefore the induction of the hypothesis, we can take the induction of the hypothesis, the existing of a group G by N. So therefore, the exists a subgroup K of G by N of order P power R minus 1. We can write it or not? So therefore,
Yes, sir.
for K by H by N is a sub. K is equal to H by N. Why? Because it's a group. We are writing K is equal to H by N for some group. For some subgroup H of G containing N, we can take here. So therefore, modulus of H is equal modulus of K by
K and modulus N.
N. Very good. By N, that is, we can write P power R minus 1 into P.
Yes.
Therefore, we can write P power R.
Into the power
Why?
of R.
Why? Because R plus
It's
1, that is,
cancelled.
we can write yes. Cancel therefore. So therefore,
It is power of R.
Therefore, P power R. Therefore, the H is the required subgroup. Therefore, the required subgroup of G of order P power R. Am I correct?
Yes, sir.
Yes, sir.
Then I'm going to the second condition here. Suppose I am taking here P does not divide the order of G. So in terms of the divide and economy, it does not order by the. So therefore, I did not tell the class equation. I will tell the class equation. Next one, the class equation I'm telling Z of G summation of K is equal to I is equal to 1 G N of Y1. This is the class equation. Next, I will tell the class equation. So there is the class. This is a class equation where Y1, Y2, and so on Yk such that this is such that we can write C Y of 1, C Y of 2, and C Y of K. We can write one. We can write it or not. All the distinct conjugacy classes or not.
Yes, sir.
Yes, sir.
All the distinct conjugacy classes, each with more than one element, each with more than one element, which is the more than one element. So which is the more than one element? So we have to write P divides here. P divides here modulus of G, and so P does not divide. P does
Z
not.
of G.
Why does not divide G? So this is a
Because-
why? Because of the distinct of the conjugacy classes. Am I correct?
Yes.
So different classes, different type of conjugacy classes. So therefore that we can write here the more than one element. So P does not divide G. So P does not divide here. P does not divide here. P does not divide here. G of N of Yi for some I 1 less than or equal to I less than or equal to K. Am I correct? So P does not divide అంటే 1 less than or equal to I less than or equal to K అవుతుందా కదా?
అవుతుంది, sir.
Now P power R divides modulus of G is equal to G of yi. N of yi implies that P power divides here. P power R divides here modulus of N of yi. N of yi. And we have N of yi less than G. So hence by the induction hypothesis. Hence by the induction of the hypothesis there is a subgroup. Hence by the induction of the hypothesis there is a subgroup H of N of yi by the class equation of order P of R. So which is a subgroup or not? Which is a subgroup or not?
Yes, sir.
Yes, sir.
The subgroup of also. So therefore, it is an odd divide. So it is the conjugacy classes. That's why we are writing the second condition. Okay.
Sir.
Any doubts for this one? Just a minute. So now what I am told the class equation. Now I am going to the class equation. Okay. Respond.
Yes, sir.
Please respond.
Yes, sir.
State and prove the class equation of a finite group. All are important. What I am telling. Finite group. So in the I will first basic concepts we are taking here. Let G be a group. All know that. Then the following conditions. What are the conditions we have to know? The set of all conjugacy classes in G is a partition of G. Then second condition, for any x belongs to G, C of x modulus of, we can write here G n of x, we can write here for any x belongs to G. Modulus of C of x, we can write G n of x. Third condition, if G is a finite, is a countable, the G is called summation of n, I is equal to 1, modulus of C x I. ఇంతకుముందు చెప్పినానా తీరంలో?
Yes, sir.
అందుకే ఈ తీరాన్ని మీకు మళ్ళీ చెప్పాలని చెప్తున్నాను. Therefore Gn of xi. So where the condition here, C of x1, C of x2, and so on, C of xn, the comma here, or all the distinct conjugacy classes. Distinct conjugacy classes in G. The fourth condition we have to prove. If G is finite, then modulus of G is equal to Z of G. Now earlier theorem I told that M is equal to J is equal to 1, G of N of yi. So these four conditions to prove in the class equation. We have to prove these four conditions in the class equation. So therefore, that's another one. And now I'm writing the statement only. Y1, Y2, and so on. Ym are such that Cy1, Cy2, and Cyn I'm writing here are all the distinct conjugacy classes or distinct
More than one element.
classes with more than one element.
One
Very
element.
good. With more than this is all. This is the statement. This is the statement of class equation. You have to write in the examination. They give the this statement. You have to write the proof. Otherwise, you can write the total statement and you can give the proof here. Understood? Let G act on G by conjugation. What is meaning by conjugation? Anyone tell me what is the meaning of conjugation? Hello? What is the meaning of conjugation? మిమ్మల్నేనండి అడిగేది. వెరీ గుడ్. ఇంకా ఎవరైనా చెప్తారా?
It's conjugate. Like opposite, sir?
ఇంకొకరు చెప్తున్నట్టున్నారు సార్.
Conjugation. Opposite లాగానా సార్?
ఆపోజిట్. ఇంకా
Conjugate.
ఆపోజిట్ అంటే ఏంటమ్మా? Changing the sign between the two terms binomial.
Sir,
Changing the sign between two terms as binomial. We can write x plus y is equal to x minus y. So x plus y is a conjugate of x minus y. We can write it or not?
Yes, sir. In the complex numbers, sir.
Yes, yes. అది చెప్పాలి. అందుకనే అడిగా మళ్ళీ.
అచ్చా అంటే ఇక్కడ వేరే చెప్తున్నా కదా సార్, కాంప్లెక్స్ మళ్ళీ తీసుకురావచ్చు అని. అదే a plus ib ఫామ్ లో. ఓకే ఓకే
తీసుకురావచ్చు. ఎందుకంటే కాంజుగేషన్ అనే వర్డ్ అదే కదా.
అదే సార్, అది వచ్చింది కానీ ఇక్కడ చెప్పొచ్చో లేదో అని డౌట్ఫుల్ గా చెప్పలేదు సార్.
తప్పు లేదు. ముందు ఎక్స్ప్రెస్ చేయాలి ఫస్ట్.
థాంక్యూ సార్.
Sir, please explain explain about conjugation.
Some explain about
Conjugation.
I told Amma, if the x plus y is there, their conjugate is x minus y. Amma, formed by changing the sign between two terms as a binomial.
Okay, sir. Okay.
Listen here, don't concentrate other things, please. So therefore, let x belongs to G on orbit of x is Gx is equal to Cx. And what is the stabilizer? Tell me. What is the stabilizer meaning? Please. Anyone tell me stabilizer? I am audible?
Yes, sir.
Anyone tell me, Amma, it is right or wrong, please?
Like which cannot be unchanged, sir.
Unchanged. What is unchanged, Amma?
Constant.
So the set of elements we have to take in here. Lakshmi Narayana, tell me. The set of
Constant, sir.
Okay. చెప్పండి. So therefore, stabilizer means Gs is equal to G belongs to G. So G belongs to G, capital G by small g is equal to the set of elements G, which is leave is unchanged there and unchanged under the action. Am I correct? That means the permutation with the positive sign. Am I correct?
Yes, in the permutations.
Yes, sir.
Yes,
Yes,
we'll
sir.
use in the permutations.
You have to tell. That is a stabilizer. Okay?
Yeah.
Okay.
Yes, sir.
Okay. Then we will go to that stabilizer. Stabilizer of A. X. So therefore, stabilizer. Just a minute. Stabilizer of X. Stabilizer of X in G. G of X is equal to mute and immute, please. N of X. So then I am continuing here. We have to prove the first 4 conditions. So we have to prove. We have to prove the following conditions here. Let G be a group actioning on a set X. Then the following hold. First one, the set of all orbits Gx by X belongs to X form a partition of X. So that all the points is G of X by X belongs to X. Is a partition of X, automatically it is forming or not?
Yes, sir.
So that is each element of X belongs to exactly one orbit. Exactly one orbit. So then second condition, for any X belongs to G, the orbit Gx is bijective. What is bijective?
One
and on to.
One and on to.
One and on to function.
Very good. Yesterday we will listen.
Sir. Yes, sir.
Yes, sir.
Yeah,
2
that's why
times you have repeated, sir.
that's why I'm asking. Very good. Bijective.
Thank
With the set G by G of X of all left cosets of G of X in G. So this is the condition 2 we have to prove. Then the third condition, modulus of G of X is equal to G of X. The fourth condition, if modulus of X less than infinity, then modulus of X is equal to I is equal to 1 to N G of Xi, that is equal to N J is equal to 1. This is all conditions I wrote in the beginning. Am I correct or not?
Yes, sir.
So again, we have to prove all these conditions. That's why I written here. So where we have to write here these conditions, where Gx1, Gx2, and so on, Gxn are all the distinct orbits, different orbits in capital X. So first condition we have to prove here. For any X belongs to G, X is equal to Ex belongs to Gx. We can write here. Ex belongs to Gx. We can write it or not?
Yes, sir.
Then we have to write here from the above condition X is equal to union of X belongs to X. And the kalipe values kabatti we are writing union of X belongs to X. Union of G of X. So why? Because Z belongs to Gx of G. Why writing intersection? Anyone tell me?
Sir, it also belongs to G of X and intersection G of Y, no, sir. Common elements.
Yes. That's why I'm writing here Z is equal to X is equal to By for some A, comma B belongs to G. Am I correct?
Yes, sir.
That's why I written here. Now for any Cx belongs to Gx, I am writing here. Cx belongs to right X here, Gx, C of X here. So therefore, automatically here, Cx is equal to C of A inverse B. We can write here In place of x, we can write A inverse by. We can write see x in place of x, A inverse by. We can write.
Yes, sir.
Yes, sir.
How?
Because in the previous step, you have written z is equal to x, which is equal to
X
by.
equal to by.
Ah, z is
when we
equal to
take it
x
to-
base
yes.
by. So in that condition, A comma B belongs to G.
Inverse by.
Yes. In the place
Very
of
good.
x, we can write it as a inverse
Thank you.
by.
Thank you. You are listening. C inverse of A y belongs to G by. So therefore, Gx subset of equal to G by. That condition may be satisfied. Gx subset are equal to G by. Gx subset of G by. So therefore it is a Gx is equal to G by or not?
Yes, sir.
Yes, sir.
So therefore we can write here Gx is equal to G by. So therefore any two orbits are either equal or disjoint. Am I correct?
Yes, sir.
Yes, sir.
Therefore, G is the disjoint union of. So therefore, G is the disjoint union of distinct. So therefore, G is the disjoint union of distinct orbits. Am I correct?
Yes, sir.
Yes, sir.
Second condition we are doing here. Gx stands to G by Gx by alpha of Ax equal to A into Gx for all A belongs to G. For A comma B belongs to G. So we are writing here A into Ax is equal to alpha into Bx. We can write?
Yes, sir.
Above condition we have to write here. Therefore, Agx is equal to Bgx. Right? We can write from the above condition.
Yes, sir.
Yes,
So
sir.
therefore, A inverse B belongs
Belongs
to
to Gx.
Gx. So therefore, the above the conditions we can write here. A inverse of Bx is equal to x.
X.
Therefore, Ax.
Bx.
X equal to Bx.
So therefore, alpha is well defined is 1 1. 1 1 or 1 1 condition satisfied. X is equal to
Yes,
x
sir.
equal to the 1. So it is
Yes,
clearly onto. It is also onto or not?
Yes, sir.
Yes, sir. Yes, sir.
How it is onto?
Well, both it is also well defined and one no, sir.
Yes, yes. So it is a clearly 1 1 and onto. So every element of G by G is a form of. We can write here. G by Gx is of the form Agx is equal to alpha into Ax. From there, so alpha is a bijection, is 1 1 and onto. So for any the third condition, for any x belongs to x, we know that we learned the above condition. Modulus of Gx is equal. From the above condition, it should be satisfied.
Yes, sir. Yes, sir.
So I did not writing above. So all the conditions you have to write same.
Okay, sir.
So
Yes.
I did repeating the conditions. So suppose all the condition x belongs to x satisfied. So you have to write the same thing in the third condition also.
Okay, sir.
Don't write from the above conditions are satisfied. You have to write all the conditions again here.
Okay, sir.
The fourth condition is since x is finite, the number of distinct orbits is also finite. So therefore, g of x1, g of x2, g of xn be all the distinct orbits of all the distinct orbits of x in G. So therefore, modulus of x is equal to modulus of gx1 plus modulus of gx2 and so on.
GX1.
Gxn.
Yes, sir.
So we are taking the orbital distinct elements. So we have write from the third condition here. Modulus of g of gx1 plus g of
gx2.
very good and so
Plus
on.
M1.
G of
GXN.
gxn.
Which condition?
Third, sir.
Very good. From the third condition we are writing
From
here.
third condition.
Third condition, very good. Therefore, summation of n I is equal to 1 g of gxn. Now we have to prove the fourth condition. Now we have to prove the fourth condition here. First, we observe that here. We observe that here for any x belongs to G, C of x is equal modulus of x, Ax A inverse is equal to x for all A belongs to G. Am I correct?
Yes, sir.
Yes, sir.
Ax is equal to what we have to write? XA
XA.
for all A belongs to G. So therefore, write x belongs to ZG.
Yeah, sir. Integers.
Hello?
Hello, sir.
Tell me.
Sir.
Can't hear you, sir. Sir, please repeat, sir.
Please, from the both conditions, we can write x belongs to ZG.
Yes, sir.
Yes,
Why?
sir.
Why it is a finite?
Finite and abelian, we are just taken it, no, sir.
Yes. Then G is a finite.
Integers.
And, G is a finite and ZG is the number of conjugacy classes is there.
Yes, sir.
Yes, sir.
That's what I'm
There
asking.
should be one exactly. There should be one element. So we have already discussed in the previous theorem also, no, sir.
Yes.
I mean,
That's why again and I'm asking why, because you can learn. It is a memory.
Yes, sir. Yes, sir.
X
Yes,
belongs to J. So therefore, the one element exactly containing the exactly one element. So we have to take here. Let's C of y1, C of y2, and C of yn with all the distinct conjugacy classes with more than one element. So from the third condition, know that. From the third condition of the know that, I'm writing again. Modulus of G sigma n I is equal to 1. C of x I is equal to Z of G. Summation of m I j is equal to 1. So plus summation 1 again. Then C of yi is equal to Z of G plus summation of m j is equal to 1. G of ny. We can write from the third condition.
Yes, sir. Yes, sir.
Now this is called as a class equation or not?
Yes, sir.
Huh?
Yes. Yes, sir.
Yeah, it's a called a class equation. Some note I will give you. Let G be a group. X belongs to G. Then orbit of X. Orbit of X is the class of X in G. Given by C of X is equal to Ax A inverse by A belongs to. Correct or not?
Yes, sir. Yes, sir.
Yes, these two conditions
Yes,
is satisfying the class equation. I'm the second condition I'm writing here. The stabilizer of X G is the normalizer given by so the stabilizer of X in G, the stabilizer of X in G, the normalizer X in G is given by n of X is equal A belongs to G, X is equal to A. So therefore we can this is called as classic equation. Are you all of you understood?
Yes, sir. Yes, sir.
Any more doubts?
No, sir.
No.
No more. No. Anyone please? Deduct the Cauchy's theorem. So deduct the Cauchy's theorem here. Cauchy's theorem from the first Silo theorem you are understood, I think. I will ask from the first Cauchy's theorem. Then let G be a and P a prime number. Correct? Correct from the first Silo theorem. Such that
Yes, sir.
Yes, sir.
this is the statement I am writing. I am not going. P divides modulus of G. Then G has an
Subgroup of order.
A of order P. Avuna?
Yeah, P to the power of R, sir. Yes, sir.
Yes, A of order P. So proof I am writing here. Since P divides here G, since P divides modulus of G. From the first Silo theorem, G is a subgroup of H of order of P. Am I correct?
Yes, sir.
He has a subgroup. He has a subgroup H of order P. Am I correct?
Yes, sir. Right, sir.
Yes,
So
sir.
then from the condition P is prime.
Yes, sir.
H is
Cyclic.
Cyclic, sir.
H is cyclic. Very good. So therefore, A is a generator of
H.
A is a generator of. So therefore, order of A is
H.
equal to modulus of H is equal to P. This is called Cauchy's deduction theorem. But you have to write in the exam. It will be came. You have to write first Silo theorem statement and their content. Okay.
Okay, sir.
I love you. Ardhamaitunnaya?
Yes, sir.
Yes, sir. Sir,
Amma.
డౌట్ సార్
అడగండి.
సార్ ఇప్పుడు కోచెస్ థీరం లో ఉన్నప్పుడు నేను ఇప్పుడు ఫస్ట్ సైలోస్ థీరం కూడా రాయాలా సార్? ఫస్ట్ సైలోస్ థీరం రాయాలి,
స్టేట్మెంట్ రాయాలి.
స్టేట్మెంట్ రాసిన నెక్స్ట్ ప్రూఫ్.
ఈ ప్రూఫ్ రాయాలి.
ఓకే సార్.
ఇప్పుడు ఫస్ట్ సైలో థీరం ఏంది? లెట్ G be a finite group, P a prime number and R is a non-negative integer. So P power R divides G. So G is a subgroup of order P over R. So then on that condition, G is a subgroup of H order of P. Avuna?
Yes, sir.
That statement you want to write, then you have to continue the Cauchy's theorem.
Okay, sir.
State and prove fundamental theorem of homomorphism of rings.
Okay.
Let R and R dash be rings and phi a homomorphism of R into R dash external U. So let R and R dash be rings and phi is the homomorphism R into R dash with kernel U. So therefore, then phi of R. Then phi of R is, what is isomorphic?
One on two will depend.
Anyone tell me isomorphic? Yesterday I told.
One on two.
Antena?
Will depend also, sir.
In particular,
బైనరీ రిలేషన్ కంపల్సరీ చెప్పాలి సార్.
binary relation compulsory. If phi is on.
Correct చెప్పిన.
No, no.
Correct చెప్పిన. ఇంకా అంటున్నారు సార్.
Correct చెప్పినారమ్మా, వినబడుతుంది నాకు.
డిస్కషన్
మీరు డిస్కస్ చేయకూడదమ్మా. అంటే నేను స్టాప్ చేస్తాను, మీరు మీ పాఠం నేను వింటాను.
లేదు సార్,
లేదు సార్, మీరు
మామూలుగానే
questions
కరెక్ట్
చేస్తున్నారు కదా.
చెప్తున్నా మీరు.
వెరీ గుడ్, వెరీ గుడ్. ఇట్లా
Sir,
ఈ టీచింగ్ బాగుందా, నేను ఒక్కరిని చెప్పుకోవడమే బాగుందా?
ఈ టీచింగ్ బాగుంది సార్.
Okay. In particular, phi is on epinomorphism. So therefore, then O dash is isomorphic. Isomorphic is to R by U. So this is a statement of fundamental theorem of rings and fundamental theorem of homomorphism of rings. So therefore, let A belongs to R. Very low strength is their class in today. U plus A belongs to R by U, and phi of A belongs to phi of R. We can write it or not?
Yes, sir.
U plus A. What is U? Is a kernel?
kernel sir.
It is a kernel. So consider in the mapping we are writing here. Consider the mapping. What is the symbol?
Psi.
Very good. Psi of
Psi,
R
psi,
by
sir.
psi of R by U to phi of R. So given by psi of U plus A is equal to phi of A for all A belongs to R. To prove psi well defined for any A comma B belongs to R. U plus A is equal to U plus B. We can write it or not?
Yes, sir.
Yes sir.
So therefore we can write A minus B. A is equal to B.
Belongs
So
to
therefore
U.
A minus B belongs to U. We can write
Yes, sir.
Yes sir.
that is equal to kernel phi.
Yes sir.
Phi of minus B is equal to 0 dash. Then phi of A minus phi of B is equal to 0 dash. Then phi of A is equal to phi of B. Am I correct?
Yes, sir.
So therefore the mapping is, mapping phi is well defined or not?
Well
Sir,
defined
well
sir.
defined.
What is the meaning of well defined? So both the conditions are satisfied. Am I correct or not?
Yes,
Yes sir.
sir.
Prove that psi is an isomorphism. A comma B belongs to R. Psi of U plus A is equal to psi of U plus B. Cross quote, sir?
Yes, sir.
Phi of A is equal to what you have to write?
Phi of B.
B. 1 1.
A minus B is 0. A
A
minus B
is equal
belongs
to
to
5.
U.
A belongs to U plus B. We can write.
Yes, sir. Yes.
Yes
So
sir.
therefore U plus A is equal to U plus B.
Yes sir.
Then phi is injection or not?
5.
Psi, not phi. Psi.
Yes sir. Psi.
What is injection? What is the meaning of injection?
It's 1.
What is injection? Tell me what is injection, anyone?
1 1, sir.
Huh?
1 1.
Okay, very good. Clearly. psi is on to psi of u plus a plus u plus b, psi of u plus a. We can write it or not?
Yes, sir.
Phi of a plus b is equal phi of a plus phi of b. We can do this one psi of u plus a psi of u plus
U
b.
plus b.
Raskochara or raskorada?
Yes, sir. Last question.
I'm doing multiplication here. It is correct?
Into your
U of a plus b. U కామన్ తీస్తున్నాము ab ని మల్టిప్లై చేస్తున్నాం చేయొచ్చా లేదా u ప్లస్
Yes,
ఇంటూ
sir.
ub ని u ప్లస్ ab ని హలో
Yes, sir.
phi of ab is equal therefore phi of a into phi of b, so this may be written as psi of u plus a into psi of u plus b. So therefore psi is a homomorphism kada?
Yes, sir.
Psi is homomorphism, hence
Yes, sir.
therefore hence what is this? Homomorphism అయితే isomorphism అవుతుందా కాదా?
అవుతుంది సార్.
అవుతుంది సార్.
అవుతుంది సార్.
చెప్పరే phi is a homomorphism and hence and isomorphism. R is isomorphic to phi of r. So therefore phi is on. What is this spelling?
Epinophism.
Already I told. Epinophism, the 5 power r, therefore r by u is equal to what we have to write? R dash we can write it or not? So it's well defined. 1, 1 and on to we have proved. So therefore it is a fundamental theorem of rings. You can satisfied or not?
Yes, sir.
Yes, sir.
Any more doubts ask me. Lakshmi Ramya ask.
Sir, no
సార్
doubt, sir.
ఒక్కసారి లాస్ట్ స్క్రీన్ పెట్టరా సార్ ఎపినార్ఫిజం దగ్గర సార్ ఒక్కసారి
వేస్తాను నేను ఐసోమార్ఫిజం అయినప్పుడు r by e కు ఐసోమార్ఫిజం అయినప్పుడు 5 పవర్ r అవుతుందా లేదా?
సార్
సో 5 పవర్ r అనేది ఎపినార్ఫిజం. సో therefore 5 పవర్ r is equal to r dash. So r by u is equal to r dash.
ఓకే సార్ ఐసోమార్ఫ్. ఓకే సార్.
Any more doubts ask me. అడుగుతున్నారు ఎవరన్నా? తులసిరామ్ గారు Ramya ask me.
Sir, no doubt, sir.
Okay. Shall I go to another problem?
Yes, sir.
Sir. Yes, sir.
Okay. All of you understanding?
Yes,
Yes,
sir.
sir.
అనుకుంటున్నా నేను.
Yes, sir. అర్థమైంది.
Define an integral domain and give one example. So that any finite integral domain is field. Define an integral domain. Like example, so that every finite integral domain has field. So this is the what they are asked that I'm writing the statement here. Just a minute.
Okay, sir.
I am writing. I'm stuck here. My pen.
Okay, sir.
Yes, a non-trivial commutative ring. A non-trivial commutative ring. R is equal R comma plus comma dot with identity is called an integral domain. As integral domain, if it has non-zero divisors, that is AB is equal to 0, and almost all that is AB is equal to 0. A belongs to R. A belongs to R. B belongs to R. So therefore A is equal to 0. R. B is equal
to 0.
You can write it or not?
Yes,
What
sir.
is a non-trivial? Anyone tell me? Non-trivial. Anyone tell me? Hello?
Sir.
What is the meaning?
Devices untaya, sir?
Amma?
Devices untaya, sir? Zero devices, sir? Non-trivial.
Inka.
Non-trivial. Yes.
Is it not equal to 0? Huh? Hello?
Sir.
Not, which is the value at least variable of the equation is not equal to 0?
The screen is not visible, sir.
Now I'm shared.
Okay.
It is not equal to 0. So therefore, this is a statement to how to
Yeah.
finite integral domain. So integral domain is integral domain is a field. Proof I am writing here. Let R be a finite integral domain and non-zero element of R. Let R be a finite integral domain. What is integral domain? What is integral domain?
There's no zero devices and
yes.
A comma B is equal to 0. A can be equal to 0 or B can also be equal. So for all A belongs to real numbers and also B belongs to real numbers.
Yes, non-zero element R. So to prove that. To prove that R is a field, we have to show that. Prove that every non-zero element R has a multiplicative inverse. Please mute and D. Just a minute, Andy.
Okay, sir.
It is stucking today. The last minute.
Screen became dull, sir.
Yes, sir. It is stucking.
Okay.
Wait.
Okay, sir.
Just a minute. I will reshare. I will close and reshare.
Okay, sir.
Now it is visible?
Yes, sir.
So therefore, sir, due to heavy the clouds is there. So any disturbance, the current will be gone. That automatically the class will be closed. Okay.
Okay, sir.
Okay, sir.
So I'm continuing. Any disturbance is there? Any power failure or any failure? The net, the Wi-Fi should be disconnected. So I will continue in the next class. Until that, I will continue here. So listen, R is a multiplicative, or is a multiplicative inverse. So therefore, R is a finite. We can write R is equal to A1, A2, and so on, AN. So therefore, the elements, we can write here the elements AA1, AA2, and so on, AAN are all the distinct elements or not?
Yes, sir.
Yes, sir.
Distinct elements are, so we can write here therefore AAI is equal to AI. So we can write here AI is equal to AI. We can write it or not?
Yes, sir.
To subset S is equal to AA1, AA2, and so on, AAN. So contains the same number, of elements as in, what is R? What is R here?
Finite
Real,
integral
sir.
domain.
Huh?
Yeah, finite integral domain, sir.
Yes.
Finite integral domain, sir.
First we have taken it.
Yes, R is an particular one belongs to S. So AI is equal to 1 for some A. So it is a commutative also, no? It is a commutative also?
Yes, sir.
It is a commutative. AA is equal to 1 also here. So therefore, A is invertible or not?
Invertible, sir.
So therefore, invertible. There every non-zero element R has. So therefore, every non-zero element R has multiplied inverse or not?
Yes, sir.
So therefore, R is a field. Therefore, R is a field or not?
Field, yes, sir.
Any more doubts? Ask me. Any another theorem which will be taught today? It will be not very important. Prove that integral domain and embedded in a field. It will take one class. We will discuss on next Friday, Saturday. Any more doubts? Ask me.
Sir, show the last page once, please.
Definitely, definitely.
Hello, sir.
Wait, amma, wait, amma, wait, amma, wait, amma. Wait, amma.
Okay, sir.
Just a minute, Andy.
Okay, sir.
Just a minute, just a minute. I'm sharing the screen again. Ask me. Tell me.
I didn't write, sir.
Okay, okay. I will share on the last day. Don't worry.
Sir, even other classes also
I
possible, sir. Only regarding algebra you are saying, sir.
I will told only algebra.
Okay, sir.
Any more?
No, sir.
Thank you, sir.
Any more?
No, no, sir.
All of you understood?
No doubts.
Yes,
Sir.
sir.
Almost
Yes, sir.
4 units covered. You have to study all these 4 units.
Yes.
Almost 4 to 5 units covered. You have to study all these 4 to 5 units. Then we can go to the another important topic. So all the 8 units, all the units did not cover in the 8 classes. That's why I'm telling only important. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Any doubts? Ask me. I will clarify. I will stay on the line. I will close.
Sir,
screen.
one thing, sir, regarding
Regarding
model papers.
I will tell in the last two classes. I will tell you.
Okay, sir.
Regarding model
Okay,
papers,
sir.
how to write, I will tell in the last
Sir,
one
one
and a
more
half
thing.
class. Ask me.
Sir, regarding these online classes, sir, sir. Few classes they are changing the timing, sir. How to know that?
Tomorrow I will
Because beginning we are missing few students.
tomorrow I will rectify and I will inform you. Okay.
Okay, thank you, sir.
In chat box I'm number giving for all of you.
Okay, sir.
Okay, sir.
The differential equation class is not run.
3 to 4:30 differential equation class is going on.
Sir, లేదు సార్ 1:30 to 3 వరకు జరుగుతుంది డిఫరెన్స్.
Yeah.
2 days నుంచి.
Yes,
No class run, sir.
1:30 to 3 DE, 3 to 4:30 real analysis.
Real analysis.
Okay.
But 8 class
yes,
भी नहीं हुई, sir.
Huh?
Differential equation की 8 class भी नहीं हुई, sir.
Differential equations.
8 class भी नहीं हुई.
Abhi, some students told in 1:30 to 3 they are taking.
Yeah, sir. What happened is
Yes, sir.
with a different login ID, we are logged in, sir. Unexpectedly, we checked it. So it was started at 1:30 to 3, sir. Right from 3 days onwards, it's 3 times it happened the same thing, sir.
Yes. As per
No,
schedule,
there's a lot of confusion.
No. 1:30 to 3 is the right time. In the website, they will change in the tomorrow. Okay.
Oh, okay, sir. Thank you, sir.
Right. Any more?
No,
Sir,
sir.
no doubts.
Thank you, one and all.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.
ఆకలి అవుతుంది ఇప్పుడు.
Any doubts? Ask me. Shall I leave? Shall I leave, Andy?
Yes, sir.